Hello friends, I am Deveshri Vaivi, working as Assistant Professor in the Department of EC, SJBIT. In today's video, I will be explaining about the TDM. TDM stands for time division multiplexing. The sampling theorem, it provides the basis for transmitting the information contained in a band limited message signal m of t as a sequence of samples m of t taken uniformly at a rate that is usually slightly higher than the Nyquist rate. An important feature of the sampling process is a conservation of time. That is, the transmission of the message samples engages the communication channel for only a fraction of the sampling interval on a periodic basis. And this way, some of the time interval between adjacent samples is cleared for use by other independent message sources on a time shared basis. We obtain a time division multiplexing system, which enables the joint utilization of a common communication channel by a plurality of independent message sources without mutual interference among them. The concept of TDM, it is explained as shown in the block diagram. Here, each input message 1, message 2 till message n, it is first restricted in a bandwidth by a low pass filter. It is actually a low pass pre-alias filter so that it can remove the frequencies that are non-essential to an adequate signal representation. The low pass filter outputs, now they are applied to a commutator, which is usually implemented using a electronic switching circuitry. The function of this commutator, it is twofold. That is, first one, to take a narrow sample of each of the n input message signal at the rate fs, and which is slightly greater than 2W, where W is the cutoff frequency of the pre-alias filter. Second one is to sequentially interleave these n samples inside the sampling interval Ts. So the later function, it is the essence of the time division multiplexing operation. So following this commutation, the multiplexed signal, it is applied to a pulse modulator, the purpose of which is to transform the multiplexed signal into a form which is suitable for transmission over the communication channel. So it is clear that the use of the TDM, it introduces a bandwidth expansion by a factor n, because the scheme must squeeze n samples derived from n independent message sources into a time slot which is equal to one sampling interval. At the receiving end of the system, the received signal, it is applied to a pulse demodulator, which performs exactly the reverse operation as that was performed in the pulse modulator. So the narrow samples produced at the pulse demodulator output, now they are distributed to appropriate low pass reconstruction filters by means of a decommutator. Decommutator which operates in synchronization with the commutator in the transmitter. This synchronization is essential for a satisfactory operation of the system. The way the synchronization is implemented, it depends naturally on the method of pulse modulation used to transmit the multiplexed sequence of samples. So, at the output we will get n number of demultiplexed message signals. So, next we will move on to the topic PPM. PPM stands for pulse position modulation. So, in pulse modulation, we may use increased bandwidth which is consumed by the pulses to obtain an improvement in noise performance by representing the sample values of the message signal by some property of the pulse other than the amplitude. In pulse duration modulation, that is in PDM. In pulse duration modulation, the samples of the message signals are used to vary the duration of the individual pulses. This form of modulation, it is also referred to as pulse width modulation or pulse length modulation. So, the modulating signal may vary the time of occurrence of the leading edge, the trailing edge, or both the edge. So, if you observe, this is a message signal m of t and this is a series of pulse carrier and this is a PDM. Here the trailing edge of each pulse, observe here, it is varied, the width here it is varied in accordance with the message signal, which is assumed to be sinusoidal as shown in this figure. In PDM, long pulses are expendable considerable power during the pulses while bearing no additional information. So, if this unused power, if it is subtracted from the PDM, so that only time transitions are preserved, we obtain a more efficient type of pulse modulation, that is this one, PPM, pulse position modulation. In PPM, the position of a pulse relative to its unmodulated time of occurrence, it is varied in accordance with the message signal. So, now let Ts denote the sample duration. Using the samples m of nTs of a message signal, let us take it as m of t. To modulate the position of the nth pulse, we obtain the signal S of t is equal to summation in is from minus infinity to plus infinity g of t minus nTs minus kp m of nTs. So, where Kp, it is the sensitivity of the pulse position modulator, and G of t, it denotes a standard pulse of interest. So, the different pulses constituting the PPM signal S of t, it must be strictly non-overlapping. This is a condition for this requirement to be satisfied, has to be the G of t, it should be 0 when t greater than Ts by 2 minus Kp into m of t max, or you can also write this as Kp m of t max is less than Ts by 2. The closer the Kpm of T max is to 1/2 the sampling duration Ts, narrower will be the standard pulse G of T, in order to ensure that the individual pulses of the ppm signal S of T will not interfere with each other, and wider will be the bandwidth occupied by the ppm signal. We assume that this equation it is satisfied and there is no interference between the adjacent pulses of the ppm signal S of T. Then the signal samples m of NTS, it can be recovered perfectly. If this condition is satisfied, then only the recovery is possible. If the message signal m of T is strictly band limited, it follows from the sampling theorem that the original message signal m of T can be recovered from the ppm signal S of T without any distortion. So this is about the pulse position modulation. Next we will move on to how we will generate the ppm waves. Generation of ppm waves. So in the previous slide we have seen the equation of ppm waves. So here the message signal m of T, it is first recovered or it is converted into a PAM signal by means of a sample and hold circuit, which generates a staircase kind of waveform which is represented as U of T. Note that the pulse duration T of the sample and hold circuit, it is same as that of the pulse duration ds. This operation we'll see the diagrams in the next slide. Then to this signal we are adding a sawtooth generator, just sawtooth wave, which yields the combined signal V of T. This combined signal V of T, then it is applied to a threshold detector. Thus it produces a very narrow pulse every time V of T crosses 0 in the negative going direction. So the result sequence of this impulses I of T, it is the output of the threshold thing. Finally you can get the ppm signal S of T by using the sequence of impulses to excite a filter whose impulse response is defined by the standard pulse G of T. So we'll see the corresponding waveforms. The first is a message signal M of T, and the second one is the staircase approximation of the message signal. And when this is combined with the sawtooth generated waveform, we'll get the composite wave after mixing the sawtooth waveform and the staircase approximation. So this is what is the signal we get. Then whenever the signal is crossing the zero detection from positive to negative, wherever it is intersecting, we will have a very narrow pulse. Every time when this V of T cuts the axis 0. So the resulting is the impulse function I of T. So then we can regenerate back the message signal. So this is the process of generating the ppm waves, generation of ppm waves. Next, we have a topic related to detection of PPM waves. So, let me summarize what we have discussed in this video. First, we have started with this time division multiplexing. Time division multiplexing, its block diagram, its working. This is basically used along with the PAM. First PAM is used and then the output of the PAM is fed as an input for your TDM. Then the PPM generation. So what is PPM? Pulse position modulation. What are the other names given? PDM, PWM, PLM, pulse duration modulation, pulse width modulation, pulse length modulation. So how these signals are generated, what are the conditions to be satisfied in order to get the PPM wave. So that is explained here. Then the generation of PPM waves. We have a block diagram of PPM generator wherein we have a message signal. That message signal is passed through a sample and hold circuit where you will get a staircase approximation, and then that is obtained using a pulse generator. The staircase approximation, it is added with a sawtooth generator. So when these two are getting combined, you will get a sawtooth generator which is varied in accordance with the amplitude of the square wave or approximated wave, staircase wave. And then that signal, it is passed through a threshold detector where you will measure or you will observe when is that signal crossing the zeroth axis, zero line. So there at that point we will have a very narrow sharp pulse. It is like a train of impulse pulses. So that is acting as a PPM. You will use a pulse shaping filter so that you will get a suitable PPM wave. So next we saw the waveforms respectively at each step. What are all the things we get? And these are all the things which we have learnt in this video. In the next coming video, I'll be explaining about how do we detect the PPM waves, how the detection happens, and then how the noise and pulse position modulation is having an impact. What is its input output relation of the slicer, what is slicer, how is it working, all those things will be discussed. And also I'll be briefly discussing about the figure of merit of PPM system, and then lastly I'll be discussing about the bandwidth noise trade-off. So whenever any system is taken, and in that system which parameter is our prime priority, that will be taken into account, and other parameters we may negotiate with that. So based on our expectation, so we'll do the trade-off. Then the quantization process, all those things will be explained in the next coming videos. Thank you.